hope you all are fine and staying safe at home. I am Ruth P. Rajeev from class 12. Today I am going to take the topic Types of Adsorption from Chapter 5 Surface Chemistry. Before starting into the lesson, I would like to recall the definitions which we have learned earlier. Definitions of adsorption, absorption, adsorbate and adsorbent. So one by one we are going to do an experiment and recall the definitions. First, we are going to do the experiment for adsorption. So for this experiment, we need a chalk piece and ink. So now let's start the experiment. First, you have to take a chalk piece and dip, and you have to pour one drop of ink on it. So for adsorption, what we learned that adsorption is a phenomenon in which the adsorbate is only bound on the surface of the adsorbent. So in this case, what is the adsorbate? Adsorbate is nothing but the ink is the adsorbate because it is only binding on the surface of the chalk piece. And what is the adsorbent? The adsorbent is the chalk piece. And so now we are going to break this chalk piece and we are going to check whether this ink had gone into the chalk piece or only it is spread on the surface. Okay, can you see this? Yes. Okay. Now look, no ink had gone inside. Look, it's white color. This is just the color of the surface, and look, this is just white color. So from this what we learned, adsorption is nothing but it is a phenomenon in which the adsorbate is attached on the surface of the adsorbent and it will not go inside, it will not penetrate inside. Did you understand? Okay. Now we are going to do the experiment for absorption. We know the definition of absorption. Absorption is nothing but in the phenomenon in which the adsorbate is entering into the adsorbent. So for this experiment we need two materials. So the materials are a tissue paper and the same ink. So now this is the adsorbent. This is the adsorbent. Why? This is the surface upon which we are pouring the ink, and this only will absorb the ink molecules. Okay. So now we are going to pour the ink, a drop of ink on this tissue paper. Just look, I am just going to pour one drop of ink. Okay, let it absorb. Just look, it's spreading apart. Okay, just now look, it is also in the front also the ink is there. Also in the back side also the ink is there, and we can open this tissue paper. The surface is just full of ink. So from this what we can understand, how we can make the definition for absorption. Absorption is a phenomenon in which the adsorbate, this is the adsorbate. Why? This is only attaching, it is only entering inside the tissue paper. The adsorbate is just entering, or it is just entering inside the adsorbent. Adsorbent is the bulk molecule in which that phenomenon is taking place. So did you understand what is meant by adsorption and absorption? Also adsorbate and adsorbent. I hope you understood this topic. So let's go into the lesson and we will learn about types of adsorption. So adsorption is of two types: physical adsorption or physisorption and chemical adsorption or chemisorption. We learn one by one in detail. First, physical adsorption. Physical adsorption is nothing but the adsorbate and adsorbent are joined together with the help of weak van der Waals forces. No chemical reaction is formed, and so no chemical bond are formed between them. So this is termed as physical adsorption. Physical adsorption requires very low temperature, and if you are increasing the temperature, physical adsorption automatically transfer into chemical adsorption. Also, physical adsorption is easily reversible. So we can make it into its reactants because weak van der Waals force alone are helping in the formation of physical adsorption. And so if we are applying some heat and giving some pressure, this physical adsorption can be reversible. Now we are going to study about the characteristics of physical adsorption. 5 characteristics are there: lack of specificity, nature of adsorbate, reversible nature, surface area of adsorbent, enthalpy of adsorption. So one by one we are going to look into it. First is lack of specificity. Lack of specificity is nothing but all gases show same adsorption, same extent of adsorption in case of physical adsorption. It won't show any special preference for any type of gas, even though it may be carbon dioxide, carbon monoxide, sulfur dioxide, nitrogen dioxide, any gases, it will adsorb in the same extent because weak van der Waals forces are binding the adsorbate and adsorbent. And next we learn about nature of adsorbate. So the amount of gas adsorbed will depend on the nature of the gas. So easily liquefiable gases like carbon dioxide, sulfur dioxide, ammonia, they will be adsorbed in a very high amount because they are having very high critical temperature, and these van der Waals forces are also very stronger at this high critical temperature. So as a result, these easily liquefiable gases are adsorbed in the more amount on the surface, on the solid. Next, we are going to study about the reversible nature of physical adsorption. Physical adsorption of a gas by a solid is generally reversible. That is, they attain equilibrium. Since they are attaining equilibrium, we can reverse it easily. And if you want to increase the amount of gas adsorbed, if we are applying a little amount of pressure, we can increase the amount of gas, because when we are increasing the pressure, the volume of the gas ultimately decreases. So more amount of gas can be adsorbed. And also, if you want to reduce the amount of gas, or if you want to remove the adsorbed gas, we can decrease the pressure, and so the adsorbed gas will be removed. And physical adsorption is an exothermic process. The physical adsorption occurs readily at low temperature and decreases with increasing temperature. Since this physical adsorption is exothermic, that is, it liberates the heat, so it can occur at very low temperature because no chemical bond is formed. And in case if you are increasing the temperature, ultimately the physical adsorption decreases. And next is the surface area of adsorbent. The surface area, if the surface area is increased, the amount of adsorption also increases. So finely divided metals and porous materials also help in the increasing of the adsorption phenomena because they provide more surface area for the adsorption. Next is enthalpy of adsorption. We already learned that physical adsorption is exothermic, and so enthalpy of adsorption is very low. The value is 20 to 40 kilojoule per mole. Why this enthalpy of adsorption is very low? Because the gas molecules are attracted, or they are attached to the solid surface with the help of weak van der Waals forces. As a result, these forces are very weak. Only low enthalpy of adsorption is there for physical adsorption. And next we are going to study about the effect of temperature. We already studied that if we are increasing the temperature, physical adsorption ultimately decreases. Why it decreases? Because it occurs only at low temperature, and so also it's an exothermic process. Only low temperature is required for physical adsorption. Now we are going to study about chemical adsorption. Chemical adsorption is nothing but when the molecules of the adsorbate are held to the surface of the adsorbent by chemical forces or chemical bonds. It is termed as chemisorption. So here some chemical reaction is taking place between the adsorbate and adsorbent, and they are forming chemical bonds, and these chemical bonds may be covalent or ionic. And we also term this chemical adsorption as activated adsorption because it requires more amount of energy to activate the reaction. Since the chemical bond is forming, it requires more amount of activated energy, high energy of activation. So we are referring the chemical adsorption as activated adsorption. Also it is irreversible in nature. As the compound is formed, we can't reverse it into its original state. Now we are going to study about the characteristics of chemical adsorption. So 4 characteristics we are studying: high specificity, irreversibility, surface area, and enthalpy of adsorption. One by one we are going to learn. High specificity. Chemical adsorption is highly specific because only the chemical reaction can happen if there is any possibility between the solid surface and the gas molecule. So if no possibility is there, no chemical bond will be formed. So chemical adsorption is highly specific. And an example for that is oxygen adsorbed on the materials and oxide formation is happening. And next is irreversibility. As chemical adsorption involves compound formation and chemical bonds are formed, so it is impossible to reverse it. And also chemical adsorption is an exothermic process. In case of physical adsorption, we learned that it is an exothermic process, but it requires very low temperature. But in the case of chemical adsorption, it requires very high temperature. So and it is very slow at the low temperature because it requires a high activation energy and high pressure. With the help of high pressure also we can increase the chemical adsorption. And surface area, like physical adsorption, for chemical adsorption also, if more surface area is present, more amount of adsorption can happen. And next is the enthalpy of adsorption. Enthalpy of chemical adsorption is high as it involves chemical bond formation, and this value of enthalpy of adsorption is 80 to 240 kJ per mole. It is more greater than the physical adsorption. Physical adsorption we learned that it is 20 to 40 kJ per mole, but here we learned that 80 to 240 kJ per mole. Next is the effect of temperature. Chemical adsorption increases with increase in temperature up to a certain extent, and then it decreases regularly. Only up to a certain extent it will increase as we are increasing the temperature, and after that point, or if that certain extent is attained, it will start decreasing, and it occurs only at high temperature because of the formation of chemical bonds. Now we are going to study about the difference between physical adsorption and chemical adsorption. It's very easy. Whatever we learned before, that's what we are recalling here. So physical adsorption arises due to weak van der Waals force, whereas chemical adsorption arises due to the formation of chemical. And physical adsorption is not specific in nature, whereas chemical adsorption is specific in nature. It is reversible in nature, physical adsorption, whereas chemical adsorption is irreversible in nature. And in physical adsorption we learned that it depends on the nature of gas, and more easily liquefiable gases are easily adsorbed. And in case of chemical adsorption, it also depends on the gas, but only if there is any possibility of reaction, only the chemical adsorption can take place. Enthalpy of adsorption is low for physical adsorption, that is 20 to 40 kJ per mole, whereas for chemical adsorption it is high, and the value is 80 to 240 kJ per mole. And high temperature is not favorable. Low temperature only is favorable for physical adsorption, and it decreases with increase in temperature, whereas in chemical adsorption high temperature is favorable and it increases with increase in temperature up to a certain extent. And no appreciable activation energy is needed for physical adsorption as no chemical bond is formed. Here high activation energy is sometimes needed. And in case of physical adsorption, it depends on the surface area. More the surface area, more amount of adsorption can take place. Chemical adsorption also same thing is happening. And it results in multimolecular layers on adsorbent surface under high pressure, and it results in unimolecular layer. I hope you understood the topic, types of adsorption, and also recall the definitions of adsorption and absorption by observing the experiments. Stay safe at home. Bye.